Hey everyone, welcome back. In this episode, I'm going to be continuing work on the e-voting application I've been doing for the past couple of episodes. I'm going to be setting up our environment to use Docker for both the production environment and our development environment. I'm going to be doing a deploy using a Ruby tool called Capistrano, and once I get it on the server, I'm going to set up Nginx to handle our domain name routing, including HTTPS. So the first thing I'm going to do is set up the Docker environment with a docker compose.yaml file. So here's the docker compose file. And what Docker Compose does, it sort of automates all the things that you could probably do on the command line using the Docker command and then all the option switches. Docker Compose allows you to sort of document that and put it inside of this configuration file so that you could run a complex set of Docker setup commands consistently every time. And every time you want to restart your application, instead of typing a really long string of options for Docker to run, you just run this file, and then you could tweak it as well as you go along and you need configuration changes. So here's the main parts of the services. We've got the web service, that's going to be our application. We've got the DB service, and that's going to be our Postgres database. So there's a few ways that we could run the database part of our application. I could do a more traditional setup where I have Postgres running as an independent application, an application service on the hosting server, and the application could certainly connect to the host server and use that instance of Postgres that way. Or I could set it up so that Postgres is running as a database on a completely separate dedicated server. I've worked with setups like that before, and that can work pretty well too, especially if you have a very large database with its own maintenance requirements. But for a small application, you could certainly run your database as its own container. You could either do one container for every application that you're doing, in which case you'll spin up a separate instance of Postgres, or if you want, you could run Postgres as a single container on your system and have multiple applications connecting to it. In fact, this is how I have my development environment set up. I have a separate project called Docker Postgres, which sits in my development directory. I go in here and I run the container so that it's always running when my computer starts. And it's kind of like having Postgres installed as a native installation on your system. You know, it runs just like you were running the Postgres service, but instead it's running through a virtual machine, which is this Docker container. And one of the things I like about doing it through Docker containers is that it's very easy to change your version of Postgres. So if you're running an application and you need to upgrade it to a newer version of Postgres, you just start up a new container with the new version. Whereas if you had it installed on your system as an application, then you'd have to upgrade the one instance of Postgres, and that could be really difficult to do. For this case, though, I think I'll do the single database virtual machine per application because I'm going to be running it on the same server that I have my U.S. Treasury yield curve website running on, and that's already using this type of setup. I might change it later. Let's go ahead and spin up this DB instance on our local machine. By the way, on my local computer, I have Docker Compose alias to DC. So every time I type in DC, it's actually doing a Docker Compose. So I do DC build DB, and that's going to build that database part of my Docker Compose file. And as you see here, I didn't set DB password. I'm going to have to set that in my environment file. So here, I already have that set up in my environment file. I just need to change the name of the environment variable. Oh, we don't have to build this because when you're referencing an image, this is already pre-built on Docker Hub, and you don't have to make any modifications to it, so you could just run it as is. Okay, now we have another problem. The network needs to be defined already. So if you notice in this configuration, I have references to network, which is e-voting, and I also have reference to a volume here. We have to create both of these manually on Docker because I have the external true flag set. So for every Docker container that you're running, you could connect it to its own Docker encapsulated network. And the reason I have it set up this way is so that the application and the database could communicate with each other as if they were on the same VPN. And when you have external set to true, Docker expects you to have that pre-configured. So let's go ahead and create these. Okay, so the network is created, and here are some of the configuration details of it. This is kind of like a little VPN for the containers. Now I'm going to create the volume. Okay, so now this volume is allocated within Docker, and all the database files are going to be stored here. Okay, so I should have just done up Postgres or post up DB because I just want to run the DB. Postgres is now up and running, and we can now log into the Docker container as if we were doing an SSH into a terminal on a remote database server. But we're going to use the docker compose exec command to open up a bash session. And now we can log into the database on that terminal and show you that Postgres is set up, and we could see all of the database tables. I went ahead and updated the port in the application to connect to the database container on localhost. As you can see, I have the container set to forward port 5445 on our localhost system to 5432 inside of the container, which is the default port for Postgres. With the application connecting to the container that way, we can run rake dbmigrate to populate this database with our table schema. Now I'm going to refresh the table listing in our Postgres session, and you can now see the created database. Now we have our database container set up. Let's work on setting up the container for the application itself. And we'll start by looking at this build instruction here. When you see build with a dot there, that means that it's going to look for a Docker file in the base directory and build off of that file. Sometimes you might have a project with multiple subdirectories with multiple containers to be built. For example, we could make a DB folder and have a special Docker file for building the database there on top of the image that we're using, in which case we would do something like build and then specify that directory. So if we do this, then it would look for a DB directory and look for a Docker file in there. But right now using the image is good enough. So let's go ahead and build a Docker file for our application. So here's the Docker file code. It's basically telling Docker how to set up a container, which is sort of like a virtual machine configuration on how it's going to run this Ruby server, I guess you could say. I'm building based on the Ruby 303 Alpine image. Alpine is a lightweight Linux distribution, and I'm getting that from Docker Hub. So here's the Docker Hub page for Ruby. As you can see, it's the official image, and I am pulling this one, 303 Alpine. I tried using 3.1, but I was having some Nokogiri compilation issues, so we're just going to stick with version 3.0 for now. We're using the package manager to add a few things to our setup that we need, like the Postgres database client. We're adding Node.js. This sets the working directory to be /app, which is where our program is going to be. And then I have it download and install all of the gems so that this application is ready to go when you build it. So let's go ahead and build this application now. Go to our command line and we'll do a docker compose build. Okay, so now the container's built, we could go ahead and run this container. And it looks like there are a few problems left to resolve. This error about not being able to find the Rails executable is caused by a problem with Rails not being on the path in this shell session. Here's a Stack Overflow post explaining the CMD instruction inside of our Docker file and how the brackets are causing this problem by opening up a secondary shell without all of the environment variables loaded, and therefore Rails can't be found on the path environment variable. The way that I'm going to fix this is by using the entry point instruction, which tells Docker to run all the commands to the bundler context in the main shell. Also, in troubleshooting this, I discovered another problem related to time zones. There's a time zone dependency not included in Alpine, which Rails needs to function, and we can fix that easily by adding the tz data dependency. So now let's go ahead and rebuild this container with the updated Dockerfile instructions, and we'll run docker compose up, and as you can see there, the database dependency is starting along with the web application. So now that the web application's up and running, we got the Rails server going. Let's try logging into the Rails console and seeing if we could access our database just to check if our settings are properly configured. And here we're getting an error in trying to connect to the database. And that's because our database environment variables are not correct for connecting to Postgres from within our Docker container. Let's take a look at our environment variables, and I'm going to try connecting to the shared Postgres instance that I have running on my host machine. By host, I mean the computer that I'm running Docker on, but it's not really because I have Postgres running in a Docker container, like I said earlier in the video. It just acts like a Postgres instance installed on the local machine, running on port 54124, and you could connect to it like such. So from within a Docker container, you can see the host machine as if it were a computer on the network using the DNS path host.docker.internal. So we'll set our environment variables to that, and hopefully we should be able to connect to that database. So now we could try the Rails console again, and when we try to access some of the data, we could see Minecraft Election as the first campaign in the database, which is what I had used in the shared testing development database earlier. Now let's go ahead and tweak our settings to access the Postgres Docker container that we've set up specifically for this application. This arrangement of a specialized Docker container for the database is exactly how I plan to set up the production server. By starting out having an isolated database instance, it's going to be easier to migrate that if this application grows bigger and I need to move the database to its own dedicated server. So if you're in a Docker container and you want to access another Docker container on the same network, you can refer to that container by the name that you specified in the Docker compose file. So to access the DB container, because our web app and the DB containers are on the eVoting external network that I set up earlier, the host names to access them are web and DB respectively. Also, despite the port forwarding of Postgres to port 5445 on the host machine, within the eVoting Docker virtual network, the proper way to access the open port on the DB container is 5432. It's only 5445 if you're outside of that network on the host machine. Now we can restart our containers, run db migrate to build all of our database tables, and if we go into the app, we have a fresh, empty database. Now the final thing I want to demonstrate is a feature called the dockercompose.override file, and this allows you to create layers of settings for different environments. This is going to be very useful for handling volumes within the web container, which I want to handle differently from my local environment and the production environment. So I created this file here called docker-compose.override.yaml, and the .override has a special meaning. So what Docker is going to do is it's going to first look at all the settings in this Docker compose file, and then it's going to go to the Docker compose override file. So in the override file, I have a separate container that's going to pull called the hello world container. So when we run our Docker compose up command, it's going to run these containers, and then it's going to run this. I'm going to run Docker compose up now, and you're going to see that it pulls in that hello world container from the override file. So we did Docker compose up, and as you can see, the hello world container spun up. Now we're going to run this a little bit differently, and this is how we're going to specify it and how it's going to run in production. Instead of just doing Docker compose up, we're going to specify the particular file that we want to run using the F flag and we're going to just specify to use the docker compose.yml file, and it's not going to run the override file. All right, so no hello world container in this case. Now, we could also have this run as the base settings, but then have another docker compose.production.yaml file that we could run on top of this, which will work similarly to the docker compose.override, but it's going to have some special settings for production. Well, I feel like I've covered enough material in this video. If you want to see the rest and how I'm going to deploy this to my web server using Capistrano, be sure to subscribe to my channel and give this video a like. So I'll see you next time.